Hello again, students. Time to take out your pen, your writing utensils, and something to write on. Class is back in session, and today we actually have a lesson. This is going to be about how you can do back of napkin combinatorics and some tips and tricks to work with multiplication and fractions to allow yourself to do on the fly calculations. Let's say you're trying to figure out, oh man, what are the odds that I actually whiff on sending this attack, right? What are the odds that this Dread Screamer doesn't get go again, or that my Boneyard doesn't turn off my Blood Debt, right? So you can make more informed decisions. This comes down to statistics, and the first thing we need to talk about is what the numbers actually mean. So whenever you do something, you have a 100% chance of outcome, right? No matter what happens, if you send a Dread Screamer, it's either getting go again or it's not getting go again. It's not like it can kind of get go again, but not really, and doesn't happen, right? So we have what we call a binary system, right? That you have two choices. There's nothing in the middle. You just have two choices, and we'll label those as hit or miss, right? So we have, right, if there's only two options, right? If your only options are you get go again or you lose go again, you flip a coin, you get heads or you get tails. If you don't get heads, you have to get tails. If you don't not gain go again, a lot of negatives in that one, you have to gain go again, right? If you don't miss, you have to hit. If you don't hit, you have to miss. Therefore, we can say with complete certainty, 100% certainty, that the odds that we hit plus the odds that we miss are 100%, right? Again, if we don't hit, we have to miss, and if we don't miss, we have to hit. There's no in between. So, how does this help us? Well, when we're looking at, let's take an example here. I'm going to continue the trend of hits in blue and misses in red. Let's say we have 5 hits and 3 misses in a graveyard. All right, that's going to give us a total population of 8. So, when we send a Dread Screamer, when we send a Banisher that's not Shadow Realm Horror, I'll tackle Shadow Realm Horror in a little bit. This is only talking about just banishing 3, and then if you have banished any number of cards. We have to we can do a bunch of math to figure out what our odds to hit are. That math would look something like, okay, well, what are the odds that we have all hits? So it would be 5, 4, 3 out of 8, 7, 6, right? Okay, so these are the odds that we have all hits, and then we can do, all right, well, what are the odds that we go hit, miss, right? Which actually, shockingly enough, is in this case the same as the hit, miss, or the hit, right? And then we look at, okay, well, what happens if we go hit, miss, and then how many instances are there of hit, miss versus hit, miss? That's a whole bunch of math that you can do if you want. I'm not doing that. I'm lazy. Instead, what we can do is we can figure out what are the odds that we miss. Usually, there's only one instance in which we completely miss, right? Again, talking about the original Monarch Banishers. The odds that we completely miss, or the instance where we completely miss, only occur if we go, all right, well, I hit one of my misses, which in this case is 3 out of 8, and now, as hopefully you all do, when you banish a card, you pull it out of the pool, right? And you then choose from that smaller population size, that smaller pool of cards, right? So here we've taken out 1 card. We now only have 7 cards left in our pool. Well, we also removed a miss. So since we removed a miss, there are now only 2 misses left in our pool. Okay, well, here, if we hit exactly 2 of the 7 misses, that's going to leave us with exactly 1 miss remaining. And again, because we pulled that miss out when we chose it last time, we're going to have 1 fewer card remaining in our pool, or in our population size. So we see that this is the odds of, this is the equation which talks about the odds of actually missing cards, or a full miss. In terms of why it's multiplication, I am not going to go into that in this video. There are plenty of Introduction to Combinatorics videos which go over why it's multiplication and not addition. And then in terms of figuring out the multiplication, 3 times 2 times 1 is obviously 6. 8 times 7 times 6, well, 8 times 6 is 48, really close to 50. 50 times 7 is 350, and then we take away 2 copies of 7, we've got 336. Therefore, we have 6 out of 336. But Heretic, I hear you say. Pat, I hear you say. You started this with percentages. 6 out of 336 is a disgusting fraction, and I don't know what that means in terms of percent. We can make our lives a little bit easier. We do this through factoring. Now, for those of you who do not remember factoring, it's when you take a larger number and you try to figure out which numbers multiply together to get that larger number. So if we take an easier example, let's look at 3/8, right? 3, the only numbers which multiply to 3 are 3 and 1, so I'm just going to rewrite that as 3. But 8, we know we can write that as 4 times 2. And then, of course, 4 can be further factored into 2 times 2. All right, so we have 2 times 2. This is what we call prime factorization, where you take everything and you break it down to your prime numbers, right? Numbers which only have factors of 1 in themselves. 1 is not a prime number. 1 is neither prime nor a composite. So, how can this help us figure out what 6 over 336 is? Well, we know that 6 can be broken into 3 times 2. Well, hopefully we do. 6 can be broken into 3 times 2. And 336. Now that's kind of a scary number. Teach you a little trick. If the sum of the digits of a number, right? So in this case right here, we have the wrong tip. There we go. We have 3 plus 3 plus 6, right? If the sum of the digits of a number equals 3, that number is divisible by 3. The original number, 3 plus 3 is 6. 6 plus 6 is 12. 3 plus 3 plus 6 is sums to 12, which is divisible by 3. Therefore, 336 must be divisible by 3. We can also see this with a quick visual inspection. 3 goes, if we look at long division, which some of you may have forgotten, we see 3. So 336 divided by 3. 3 goes into 3. 3 goes into 3 once. 3 goes into 3 once. 3 goes into 6 twice. 112, right? 336 divided by 3 is 112. On top of that, 112 must be an even number. It ends in a multiple of 2. So we can see pretty quickly that we have 6 in our numerator and 6 in our denominator, right? Numerator being the upper part, denominator being the lower part. Again, for those of you who may have spent a little bit too much time outside of school. What is 112 divided by 6? Well, divided by 2? Well, 100 divided by 2 is 50. 12 divided by 2 is 6. Therefore, we have 50 plus 6, so we have 56. So what this tells us is, after all of this nonsense, we see that we have a 1 in 56 chance to miss, to completely miss here. What does that translate to in a percentage? Well, 1 out of 50 is 2%. So we're looking at sub 2% chance to miss. I truthfully don't know exactly what 1 out of 56 is, and honestly, it doesn't really matter at that point, right? We look at this and we say we have a greater than 98% chance to hit. Does that mean we're guaranteed to hit? No. But we have a greater than 98% chance to hit. Another way you can make your life easier is, let's take a look at these numbers. Now, one of the things that you probably remember is that you can multiply in any order. Initially, that doesn't really help us. Keep in mind that fractions are just division. Hopefully, you all remember that. And division is just multiplication, right? You can manipulate division in such a way that it is multiplication. For instance, let's take another look at 3/8. We have 3 out of 8, right? We have a total total number of pieces of 8, right? There's 8 total pieces. We have 3 of those pieces. Well, that's the same as having 1/8 plus 1/8 plus 1/8, right? We have 3 different copies of one piece of 8. But when we have any number of different copies of the same thing, well, that's just the number of copies we have of that thing times that thing. So hopefully this illustrates to you why we have 3/8 rewritten as 3 times 1/8. We can do this with 2/7, right? Bring that down here. Make this 2 times 1/7. And then finally bring this 1/6 down. We don't have to actually do anything with it. It's already 1/6. That's fine. Again, the order in which we multiply does not matter. We can go through and we can do all of this nonsense. And end up with 1/56. You have fun with that. There's a much easier way. What if we take 2 and 1/8, right? Hopefully we all remember that 2 is a factor of 1/8, especially since I put it up here. This is going to give us 2/8, which is 1/4, right? 2 times 4 is 8, therefore 2 is 1/4 of 8. So we can take that 2 times 1/8, right? Because the order in which we multiply does not matter. And we can put it back in here, right? So now we have 3 times 1/4 times 1/7 times 1/6. Suddenly, this is a lot easier to deal with. Now, you probably look at it and you say, well, this is still nasty. This doesn't really help me. But we're not done. Again, hopefully the astute among you will notice that we have another pair of numbers we can combine. We have 3 and 1/6. Well, 3 is 1/2 of 6, therefore 3 times 1/6 is 3/6, which is 1/2. Suddenly, we don't have 3 times 2 times 1 divided by 8 by 7 by 6. Suddenly, we have, not the denominator there we go. Suddenly, we have 1/4 times 1/7 times 1/2. 1/4 times 1/2 is, of course, 1/8. 1/8 times 1/7 is 1/56. We get to the same end position doing less strenuous math. Are there more steps in here? Yes, there are more steps in here. But the question becomes, how strenuous are those steps? And that's really important if you're trying to do this on the fly at a tournament, right? Especially if it's, round 6, 7, 8, stuff like that. You're a little bit tired. You want to use as little brain power as possible so that you have as much energy to make the correct decisions as possible. After all, that's why you would be doing this. Take the steps which are the easiest, which open you up to as few mistakes as possible. Now, I spend pretty much all day, every day thinking about math. It's quite literally my job. I still take these shortcuts because, again, it uses as little brain power as possible. Why would you use all of that extra brain power to do the more strenuous math when you can save the brain power and put it to other things like making other correct decisions in the game? So look at the numbers you're given. Try to find those little shortcuts. And also, it makes it easier to keep those values suspended in your head, right? Which is easier to remember? 1/4, 1/7, and 1/2, or 3/8, 2/7, and 1/6? Hopefully you'll all say 1/4, 1/7, and 1/2. Let's take a look at another example, just so you get more of a feel for how these numbers can kind of work out. So let's say Jimmy's playing Levia, and he's sending a Monarch Banisher, and Jimmy has 14 hits and 8 misses. First thing we have to do, we have to determine the population size, right? That is step number 1. Determine population size. For those of you who do not have a background in mathematics, population size is just a very fancy way of saying how many total things do we have. 14 plus 8 is 22. Therefore, our total population size is 22. The total number of cards is 22. The next thing we have to figure out is what's our chance to miss. How do we do that? We set up our combinatorics problem. Again, the only way we're going to miss is if we hit 3 misses in a row. So when we set up our combinatorics problem, we have to set it up as, set up problem. Total misses. Let's say n is the total misses. And P is our population size. We're going to set up the problem as n over P times n minus 1 over P minus 1 times n minus 2 over P minus 2. This will always give us the correct product. There might be something you can do here to make things a little bit easier, but that also requires a significantly higher level of mathematics than I think a number of people want to engage with. So this is the easiest way to go about it. So here we're going to say we have the total number of misses. 8 is our total number of misses, and 22 is our total population size. Now for the next step, it's going to be over the total population size minus 1, over the total population size minus 1, and then for our final term, our final factor, total population size minus 2. Next, we're going to say, all right, well, we had 8 misses initially. 8 minus 1 is 7, and 7 minus 1 is 6. Hopefully you notice that there's actually some really easy to use numbers here. Sometimes it works out that way, doesn't always. The odds that there's no simplification you can do are incredibly low. There's almost always some amount of simplification you can do. If you watch through some of my previous videos, you may have seen instances where I can only simplify maybe once instead of multiple times, but here we're actually pretty lucky. We can simplify a number of times. 7 out of 21, if you remember your multiples of 7, 7 plus 7 is 14, plus 7 is 21, therefore 21 is 3 times 7, so we end up with 7 over 3 times 7, and that cancels out, we're left with 1/3. Here we have 6 over 20. 6, as I established earlier, is 2 times 3. Hopefully you remember that 20 is 10 times 2. So we end up with 3 times 2 over 10 times 2. And of course that becomes 3/10. And then here we have 8 over 22. 8 is 2 times 2 times 2. 22 is 11 times 2. And so we have 11 times 2 over 4 times... 4 times 2 over 11 times 2. There we go. That's how fractions work. And again, these cancel out and we'll be left with 4/11. So we see that instead of having to deal with 8 times 7, 8 22nds times 7 21st times 6 20ths, we actually end up with 4/11 times 1/3 times 3/10. But it actually gets even easier, right? Here we have a 3 and a 1/3. They cancel out. On top of that, this is 2 times 2. This is 5 times 2. And so these will cancel out. And we end up with a 2 out of 55 chance to miss. You can simplify this to be about 3%, somewhere in that realm. Again, the exact number isn't important. We know that this is somewhere between 1/25th and 1/30th. 1/25th is also known as 4%. 1/30th is just over 3%. We know that this is somewhere between like 3.3 and 4% chance to miss, right? And the way I was able to do that is we know that 2 out of 60 must be less than 2 out of 55, which must be less than 2 out of 50. Come on. There we go. Thank you. 2 out of 50, and doing a little simplification, right? This is 1 out of 30, which must be less than 2 out of 55, which of course must be less than 1/25th, right? So we know that our odds to miss fall somewhere between 3.33 and 4. So we have we have a better than 96% chance to hit. Very easy, hopefully very easy to figure out on the fly. This is how you go through and you figure out these numbers on the fly. You figure out, am I going to miss? Am I going to hit? What are the odds that I miss? And you'll see actually the odds that you miss are pretty low, even in what appears to be an unfavorable situation. So we'll do one more example, this time with the graveyard that isn't as stacked. Let's say we have 4 hits and, I don't know, 7 misses in our graveyard, right? This is an awful graveyard, right? 4 hits, 7 misses. Everybody would look at this and despair. Now again, we're looking at the total chance to miss. All we care about is our chance to miss. So we're going to have 7 times 6 times 5, right? Because every time we pull a miss, we pull 1 miss out of the population. 11, come back. 11, 10, 9. Now, there's not a lot we can do with 7 and 11. They are prime numbers. We can't really touch them. But we can move things around over here. We can swap things around. So we have 7/11 times 5/10 times 3 times 2 over 3 times 3, right? 6 is 3 times 2. 9 is 3 times 3. These are going to cancel out. This is going to become 1/2. So this is going to give us 1/2 times, actually, let me rewrite this, 7 over 11 times 1/2 times 2/3. Now, again, we have the same number in the numerator and denominator. These are going to cancel out, and we see that our odds are 7 out of 33. So each 33rd is approximately 3%. So the odds that we miss here are about 21%, which not stellar, right? We have 4 misses and 4 hits and 7 misses. The odds that we have a 21% chance to miss, but that also means that we have a 79% chance to hit. We have about an 80% chance to hit. So when you look at these really bad graveyards, it's really easy to despair and go, oh my god, the odds that I hit are so low. But they're actually pretty high. As we can see here, it's about, I may actually be like 23-ish%. It actually is about 22, 23-ish%. But the point is, you have a better than 3 and 4 chance to hit. And you know, when we think about certain choices we make in deck construction, right? We make small changes. We make important changes to have smaller impacts on our odds to do things. So don't really despair when it comes to having not the best graveyard. Are there better odds than you want there to be that you'll miss? Yes, of course there are. Right? As soon as you move past 2 misses in your graveyard, you introduce a chance to miss. Quick overview of why that happens, right? We have 2. Let's do this properly. So now let's take a look at some Shadowrun horror math. And it's a little bit more complicated, but it gets you to the same place in a couple more steps and can be done 2 different ways, both of equal complexity. So let's go back to our example of 5 hits and 3 misses, right? 5 hits, 3 misses. Total population size is 8. So if you want to determine if Shadow Realm Horror gains go again, we need 2 hits out of our 3 pulls. Okay, well, surface level, how do we determine if we get 2 hits out of 3 pulls? Well, we have to hit once. We're going to pull that hit out of the population. We have to hit again. We're going to pull that hit out of the population. But then we have to miss, right? If we want to say, okay, what are the odds that it just hits twice? Now, of course, every time we take any card out, we reduce the population size by 1. And we're here. 5 times 4 times 3 is 60 over, 336. Again, not the nicest thing to work with, but hopefully the astute among you will notice. We have 1/2 here and we have 1/2 here. So this isn't really 5 times 4 times 3. It's really 5 over 7 times 2 times 2, which is, of course, 5/28. And that's obviously, those are the odds that it gains go again, right? No. Because we also have to think about, well, what if our first pull is a hit? Sure. But then our second pull is a miss. And then that would require our third pull to be a hit, right? If we want to have only one miss in the cards we've pulled. And on the surface, this is a different problem. Except not really. Remember how I told you that the order in which we multiply doesn't matter? Hopefully you remember that. Well, what if we take this and, well, we can just move these, right? Because it's really 5 times 4 times 3 times 1 over 8 times 1 over 7 times 1 over 6. Well, if the order doesn't matter, we can rearrange our numerators and denominators however we like, in any order we like, so long as we don't change the values, right? We don't suddenly make the 8 a 9 or switch a 5 for a 7 or something like that. As long as our numerators stay in the numerator and the denominators stay in the denominator, the order in which they appear doesn't matter. Which means that if we were to take, ooh, that's not what we want. Hello, thank you. If we were to take this 5 and 4 and we were to have a miss first, that's still the same equation. It's still the same problem to be solved. Again, the numbers are just presented in a different order. So what that tells us is, when determining the odds of getting only 2 hits out of Shadow Realm Horror, it's just whatever this is 3 times, right? Because we have hit, hit, miss, hit, hit, miss, hit, or miss, hit, hit. Those are our only options. So the total percentage, the total odds that we get only 2 hits are 15/28, which is just better than a half. Not really that good, except I'm still not giving you the whole truth. Remember, Shadow Realm Horror doesn't need you to hit exactly two times in order to get go again. It needs to hit at least 2 times, which means that if we hit 3 times, well, then it also gains go again. Okay, well, how do we figure out if we hit 3 times? Well, if you want to take a moment, think about how to do it, but if you don't worry about it. We just need to say, okay, well, what are the odds that I pull one of my hits, and then I pull one of my hits, and then I pull one of my hits? And of course, every time we pull a sample out, we reduce our population size by 1, and here we go. 5 times 4 times 3. Now, in this exact instance, the numbers are exactly the same. Do not expect the numbers to be the same every single time you go through this. Expect them to be different. But thankfully, in this example, we know that the numbers are the same, so we're going to get another 5/28, which means that the total odds that Shadow Realm Horror gains go again in this example are 20 out of 28, which then can simplify to 5/7, right? 5 times 4, 7 times 4. This is about 71% odds it gains go again. Not the best, but not the worst. You can also do this going the other way, right? Again, the odds that it gains go again are equal to the odds that it does, are equal to 100% minus the odds that it doesn't gain go again. And the way you would do that is we would go back to the odds that we don't get a single hit, right? Which is 3 times 2 times 1 over 8, 7, 6. And this was the first thing we did. And we know that that's going to give us 1/56 chance. Now we have to look at the odds that we only get one hit. So, what are the odds that we go miss, miss, hit? Well, again, we have numbers we can work with. This is 1/4. This is 1/2, right? 3/6 is 1/2. 2/8 is 1/4. We already did 7 times 4, right? So that's going to give us 5 times 1 over 4 times 7 times 2. This is 28. 2 times 28 is 56. Therefore, we get 5/56 as the odds that we only get one hit. Except again, we have to look at this as, what if I pull my hit first and then my 2 misses, or a miss, a hit, a miss? We see that we still have that times 3 here. So the odds that the total odds that we only get one hit are really 15 out of 56. And the total odds that we miss are 16 out of 56. 1/2 of 56 is 28. So that's going to be 8/28, or 4/14, or 2/7. And we see here 5/7 plus 2/7 is going to give us 100%, 7 out of 7. So you can see that this works both. This works whether you're checking for the hits or checking for the misses, but in this case, you have to do probably the same amount of work regardless of whether you're checking for hits or misses. So it's probably, it doesn't really matter which way you go. Now, just to be fully transparent, if we were to go back to that original example, right, where we were just checking for one hit, you would have to, instead of just doing this one multiplication here, you would have to do all of this, and all of this. That's why it is more efficient and easier to simply determine your odds of missing rather than trying to determine your odds of hitting, because you have to do this, this, and this. Okay, let's take one more look at some Scabskins math. Now, rolling Scabskins is scary. Every time you roll Scabskins, especially in a higher tension setting, you see every time you roll, you've missed in the past, and everything it's ever cost you, and that makes it really difficult to roll. But they're actually the most busted shoes in the game. Here's why. So we have a 1 out of 6 chance to get 0 AP. We have a 2 out of 6 chance to get 1 AP. And we have a 2 out of 6 chance to get 2 AP, and a 1 out of 6 chance to get 3 AP, right? And this is going to cover a roll of 2 or 3. This is going to cover a roll of 4 or 5. This obviously covers a roll of 1, and this covers a roll of 6. Now, when we look at the expected outcome, we're going to take a look at something a little bit different. The expected outcome of any roll of Scabskins, it's the total value we expect to get times the odds of getting that value. So, if we look at our expected AP per Scabskin roll, we have 0 times 1/6 plus 1 times 1/3, right? 2 sixths is 1/3, plus 2 times 1/3, plus 3 times 1/6. This right here can be simplified to 3 times 1/3, right? Because this is x times y plus z times y, or y times x plus z times x gives us y plus z times x, plus 3 times 1/6, and this everybody hopefully recognizes now is 1/2. This is just going to be 0. So here we see that our average AP is 1.5 AP per roll. That's assuming you're not using gambler's gloves, right? If you're using gambler's gloves, the math gets even better, obviously, for only that single roll. But you are gaining 1/2 action point per Scabskins roll on average. Is that going to happen in a single game? No. There is no such thing as the law of small numbers, only the law of large numbers. But when you worry about rolling Scabskins, mathematically it is correct to roll Scabskin leathers. Now, shouldn't always roll it. Make sure that when you roll Scabs, there's actually a reason to do it. Don't just roll it to roll it and go, oh, well, maybe I'll be able to do something. Roll it when it makes sense, right? Roll it when that extra action point will win you the game, or that extra action point is the only thing that will get you back into the game. Don't roll it if maybe you'll get a little bit of extra damage, but if you miss it, you'll just lose, because then you're just asking to lose. So those are the brute math things I wanted to go over. If there was something I missed, if there's something else you want me to cover, please let me know, and I will put together a video.